Welcome to Dr. Carlson's Science Theater. This week we're going to talk about light. In particular, light has two properties. It's like a wave and it's like a particle. And when we say it's a particle, it's because light comes in little tiny packets and they travel in these little packets. Most people are aware that electromagnetic waves are the same thing as light. We're going to demonstrate for you today just how we know that light behaves like little tiny packets of energy. So to do this, we're going to use a bunch of different colored LEDs and this sheet of phosphorescent paper. Now this paper, when light shines on it of the right energy, will then activate and then glow with some energy. And what's really happening is a little packet of light, a little packet of energy of light will hit the paper and knock an electron up to a higher energy orbital, and then that electron will fall back down, and when it falls back down, it'll give off light. And so you need to kick it hard enough. And so only certain energies of light will be able to kick it hard enough. Now, light comes in many different colors. It's called the electromagnetic spectrum. So there's red light and purple light. Red light is low energy light, and purple is pretty high energy light. There's also colors of light that we don't talk about very much, but microwaves are a kind of light, as are X-rays and ultraviolet rays and infrared rays are all different colors of light. So we're going to talk a little bit about the rainbow. We're going to demonstrate just how certain colors of light are enough to get this paper to glow, because those colors are high enough energy. In other words, each photon in that color has enough energy to make the paper glow. So if we start off with some red light, okay, and then we're going to shine the red light on our paper here, all over the paper, you can see that the paper does not really glow, okay? And then, just to prove that the paper will glow at some point, I'll use a little white light here, see? And you can see that white light does make it glow. So white light is the combination of all kinds of different colors of energies of light. And colors and energy are sort of two different ways to talk about light. Each color of light has its own energy. So you see that white light has can activate the paper. Next we're going to go with some orange. And orange, if I draw on the paper, doesn't create any glow. So that means each packet of orange is not enough energy to make the paper glow. So then we're going to take some yellow and we'll shine some yellow on the paper. Again, no glow. So that means the yellow light is not strong. Each packet of yellow light is not strong enough to kick that electron up high enough to get it to glow. Now green will just barely make the paper glow. If you really look carefully, you can see the paper starts to glow. And then we go to blue. Blue is higher energy yet, and blue definitely gives you enough energy. Each packet of blue light, each photon of blue light is enough energy to make the paper glow. It kicks the electron hard enough to get up high enough so that it'll start up high and drop down and give off that light. Finally, we have some purple and slightly ultraviolet light. And this clearly is strong enough. This bright purple here, you can't actually see all the colors. It's right on the edge of vision. This is actually strong enough to cause the paper to glow very nicely. Okay. Now you may argue with me. Okay, maybe it's not that the colors are the high enough energy. Perhaps if I had enough red light, it would cause the paper to glow. Well, that would be true if light were just a wave. Okay, but I can show you that if I get a laser pointer, it is not activating the sheet of paper at all. There's no glow coming from the sheet of paper. That's because even though there's lots and lots of photons, lots of red light there, okay, they don't combine together, not normally, to activate the paper. You can't kick the electron twice, as it were, all right? And so if it were just a wave, then enough red light could combine together to get the paper to glow. But since it's actually coming in little packets, each individual packet gives a little kick, but never high enough to get it up high so that it can then fall back down and give off the green light, okay? Even a green light laser pointer, okay, green being high energy than red, and you can see it's very bright on the paper here, just barely leaves a little trace behind. It's not quite strong enough to activate the paper. Okay, and so, because blue light and not any color before blue will activate this paper, we know that all the colors below blue are too small of an energy to activate the paper. Okay, and all the colors above blue are high enough energy, and because strong red light, lots and lots and lots of red light, does not activate the paper, that's how we actually know light is coming in little tiny packets that are kicking those electrons up. And if it was a wave, enough red light would cause the paper to glow. But since it's not just a wave, it's actually little tiny packets or photons, then we can see that because the blue packets of blue are enough to light up the paper, we know that light is coming in particle form. In other words, photons. So we'll see you next time, and have fun playing with LEDs.